Okay, once again, I've drawn my 3v vector. I drew it a little too steep. You know, it goes over the same as it goes up, and this one's gone up a little more than it's gone over, so it should have been a little lower. I draw my u vector. I think I did a fairly good job with that one. I draw a line through the u vector, parallel to the u vector, through this initial point of both u and 3v. And I draw my w vector out here at the tip of 3v, the same way I did previously. And I'd have the line through the tip of this thing parallel to w. These two lines intersect up here, so I know that if I move this far in the direction of u, and then this far in the direction of w, I get 3v. I estimated that this vector is 5 times this one, and that this vector is about 6 times this one. Okay, I did better, but I didn't do well. However, if v had been drawn a little lower, I'd have had a bigger number here, and w probably should have been drawn a little steeper, so these numbers both would have come out just a little higher, as they do. Okay, in terms of the numbers, then we ask, what multiple of u and w, what multiples of u and w add up to 3v? Well, u is this, w is this, v is this, so 3v is this. How do we answer that question? Well, we write the equation. We don't know what the numbers are. We know it's probably not so that 5u plus 6w equals 3v, but we find out what does equal 3v. Instead of 5 and 6, we'll use the symbols a and b to stand for the right numbers. Okay, so a and b stand for the right numbers, and au plus bw then is what we get when we multiply u and w by the right numbers. And if those numbers exist, then we're going to find that they're right numbers such that this sum is equal to 3 times the v vector. Now we just do some arithmetic, basically. Well, a little algebra. Okay, we solve this equation for a and b. Now, as the equation is written, we can't solve it for a and b because we have to have the components of u, w, and v in order to do that. Well, naturally, if we're talking about u, w, and v, we're going to use the components of u, w, and v, so we plug those in. We have au gives us a times 0.43, bw gives us b times 0.7, negative 1.5, and 3v is 3 times the vector 3, 3. Okay, well, what do we do with this? Now, at this point, I suggested, well, you should be able to solve this. Of course, you see the matrices are going to come into view here, and that should make you very happy. It's going to be kind of interesting the way this works out to give us a matrix equation or an augmented matrix. Well, let's see how that works. Now, you see if you can get from here to a matrix, or see if you can get from here anywhere. What do you do if you see this expression? You multiply through by the a, you get 0.4a3a. You multiply through by the b, you get 0.7b, negative 1.5b. You multiply through by the 3, you get 9. Well, that's progress. Okay, now what do? Well, you're adding these two vectors. The 0.4a is how far we go in the x direction for this one. 0.7b is how far this one takes us in the x direction. So we add the 0.4a and the 0.7b to find out how far we go in the x direction when we combine these vectors. And then we add the 3a and the negative 1.5b to get how far we go in the y direction. And how far has to equal 9 in the x, 9 in the y. Meaning that 0.4a plus 7b has to equal 9, and 3a minus 1.5b has to also equal 9. And so the fact that we have to have the same x displacement for these two vectors to be equal, in other words, the x displacement here has to equal the x displacement here, gives us this equation. And setting the y displacement equal to y displacement, because those displacements also have to be equal if the vectors are going to be equal, we have 3a minus 1.5b equals 9. That's a set of simultaneous equations in a and b. We can solve that in either of two ways. Okay, we can write down an augmented matrix for this system. Here I've done that. Or we could write out the matrix equation for this system, and I've done that here. You can check and see that this matrix equation is identical to these two equations. And you can understand that this augmented matrix represents these two equations where A and B are the two variables. Instead of X and Y, we've got A and B, but we could have any symbols for these variables. It doesn't change the way we set up the augmented matrix. Well, we could find the inverse of the A matrix and use that to solve. And there might be situations where that's the most efficient thing to do. For example, if you're trying to do this with several vectors, not just the 3v vector, if you're trying to find out what multiple of u plus what multiple b equals each of 15 different vectors, it's very efficient to calculate the inverse of A and then multiply that by each of the 15 vectors in turn to get your values of A and B. Okay, so this could be a very efficient thing to do. We're only doing one, we're only checking for 3v, so I chose to go ahead and reduce this matrix. That's, just reducing this matrix is only part of what you have to do to invert this matrix. Now, of course, it's a 2 by 2 matrix, so there's a simple formula you can use to invert it, but we don't want to do that because you can't do that with matrices in higher dimensions. We want to do everything in 2 dimensions the way we would do it in 3, 4, 5, or 15 dimensions. And we wouldn't really be doing the calculations ourselves in 15 dimensions, but we'd be setting them up. Okay, well, here's our augmented matrix. We bring this augmented matrix down, row reducing in a very straightforward way, and I got A approximately equal to 7.3, B approximately equal to 8.5, so that 7.3u plus 8.5w should equal 3v. Now, actually, in looking at these numbers, my 8.5 was probably a little low. It's probably more like 8.7. And the 7.3 is probably more like 7.4. And I've got the approximately equal here, so I'm allowed to make approximations from this point on, and you can get them more accurate if you want to, but you understand how this is done. And you understand this conclusion. And how does this conclusion compare with my estimate? Well, obviously my conclusion must be wrong because it doesn't exactly compare with my estimate, which must have been right. Or maybe I have that backwards. Yeah, okay. It's my estimate that I know to be very approximate. It's not that far off by about 50%. Well, that's kind of far. But numbers are kind of in the right proportion. So don't think I did too badly, considering I was drawing this from all kinds of angles and I got my v vector too steep. Okay, so we have a pretty good chunk of understanding out of this, and we see how these arrows in the plane how questions we can ask about these arrows in the plane lead us to equations that we interpret in a way that involves augmented matrices or matrix equations.